Hello and welcome to my channel, and as you can see, today I will talk about this Fnirsi DSO TC4 10 MHz oscilloscope, signal generator and component tester. We had something like this from Fnirsi already. Here it is, TC3 model, older model than this. It offers almost same things like this, except TC3 is 500 kHz oscilloscope, while this one claims that it's 10 MHz. We will see that later. Here is all what you will get with it. There is no, I didn't see that there are different sets of equipment which coming with this. I think it's just one set. So there is oscilloscope probe with adapter, MCX connector to BNC, adapter, which you need if you wanna connect an oscilloscope, standard oscilloscope probe to this oscilloscope. Same case like TC3, same MCX connectors. So I don't know if that is good or bad. Me personally don't like these connectors. Over time, over a lot of usage, they will become loosey. But that's my personal opinion. So let's start from oscilloscope mode. Oscilloscope mode. There we go. There is 10 kHz going out from this, but he says 400 Hz. Let's go in auto mode and see what going to happen. Yeah, 10 kHz, 5 volt peak to peak. That is what I sending from signal generator. So to not bother you too much, let me set megahertz. Now it's 1 megahertz. Sine wave, of course. Let me see if I can stretch it. Yeah, quite nice. Still 5 volt. So let's go 2 megahertz. Still 5 volts peak to peak. Okay, already can be seen. Let's hit auto. So you see, confirm that. It's 3 megahertz, and already I can see a little drop in peak to peak. It dropped to just a little. 4 megahertz. As going higher and higher, it drops down, as you see, peak to peak, and I assure you, peak to peak stay 5 volts. Watch my previous videos where I confirmed that peak to peak voltage stays steady even on 50 megahertz on this signal generator. So 5, 6, no, now we are on 5, already 4.5 peak to peak, so it's starting to lose voltage, to be inaccurate in voltage measurement. Let's go 6, 7, 8, 9, 10. It's claimed 10, but peak to peak voltage dropped to 3.5 7 voltage. And now on the screen I will show you something. They say rule. I will place link below in description to this web page. They say, as you can see on the screen, oscilloscope bandwidth is specified as the frequency at which a sinusoidal input signal is attenuated to 70.7% of the signal's true amplitude, known as -3 decibels point. 70% of true signal amplitude. Output signal amplitude of 5 volt and TC4 showing 3.7 volt. 70% of 5 volt is 3.5 volts. So actually, according to that rule, Fnirsi showing clear 10 analog bandwidth of 10 megahertz. Let me go out, set it's at the frequency of 1 megahertz. Sine wave, now square wave, it's showing properly. As you can see, square wave is okay. This is pulse, okay. Triangle, okay. Partial sine wave, I don't know what they mean. It's all same like. And this is something I wanna show now. It's CMOS signal. At my knowledge, CMOS signal is all in above in plus voltage, so it does not go to minus. And look at how it's showing CMOS signal. It's not real. It should go up. That is what I know. It should be above central line, above 0 voltage. This is straight line DC voltage, and see it's at 0. Half wave shown okay. Full wave okay. Stairs, just noise. So that is about oscilloscope. Oscilloscope quite usable. I confirmed claimed bandwidth of 10 megahertz. So it's nice little oscilloscope. Very nice. Nice job from Fnirsi. Now component tester. Let's see. This toolbox needed if you're going to use any other equipment like humidity, temperature sensor, only temperature sensor, infrared decoding, voltage test up to 40 volts. From this here test I will just use Zener diode because test up to 40 volts. Let me take some Zener diode. SMD 22 volts. Can I attach it? And anode like this. And it's confirmed 22 volts. That is very nice feature on this device. For low resistance test, I made these, and to confirm total resistance between this, let me show you exactly what I mean. This is like this. So let me check resistance of these so we can can do precision test. $56 million resistance of these leads. Remember that 8 millions. Yep, 8 million, so 16 total resistance of leads. Very important in next test. Now let me take this. We will start for 0.1 ohm. Let me show you that 0.1 ohm. $105 millions should be measured here. So what Fnirsi going to say? That is my question. 0.4 ohms. Is that true value? 0.1, it should be like 0.170, 180 proper value, but this is too much, really. Let me show. That is huge mistake for low resistance. This is what we should receive on Fnirsi. Total resistance of everything included 206, 207 millions. Do you want more confirmation about this? You remember this? How I will do this? I will have to keep one with hand and another like this. It's just how strong I can keep these connections. As you can see, now we have almost same value like Fnirsi, and this is Zoe. To see this against, let me show you on this one. So in reality it should be 210. 0.3 ohm. Even this TC3 is more precise than TC4. I'm sorry, Fnirsi. Let me see. 0.5 ohm. Huge mistake. Really. Look at it. 1 ohm. Let me see when it will start measured properly. 1.4 ohm. So on all measurement it adding like 0.3 ohms. Very bad. On low resistance 100 kilo ohm. Finally it started to show proper result. Mega ohm 0.9 mega ohm, and resolution is low, just 0.9, no more. 10 mega ohm show like 8.1 mega ohm. Access, setting, calibration. there is no calibration. Let me see what it will do with this LED diode. 2.7 volts LED diode. Okay, nice, blinking at least. 2.9 volt, we can accept that, like good. 10 picofarad, I doubt, really. But its component tester, it should test. $12 picofarad for 10 picofarad, we can accept that. Even I don't think it's proper value. Now you see. $11.3 picofarad, so we will accept then that 12 picofarad. 33 nanofarad. $31.4, we can accept that, I think. Yeah, 31.6, yeah, same result. Always discharge before measuring because you can damage instrument if not discharged. Electrolytic capacitor. $228. Usually it's shown as 222. So a bit mistake, but acceptable. I really like this small from Zoe because it's so precise and you can trust it very much. Also this one for measuring internal resistance of batteries and low resistance when properly calibrated. It's perfect instrument really, with coming from Fnirsi, same company who made this. Yep, you see. And this is what I like at this instrument. It clearly detects everything about this MOSFET. Everything you need to know. It's some kind of low inductivity, but let me see. Yep, this is very nice inductance test. 1.5 millihenry. Let me see what's written on top of it. 162. Very nice measurement confirmed. To check, it's 1 kilohertz signal, so I don't know what's maximum. I just wanna check. 1 kilohertz square wave. Let me see what we can do here. Okay, you see. Different waves. Nice. A lot of different signals. Very nice. almost same like on my big signal generator. Set of signals. 50 kilohertz is max. This one says 28 volts peak to peak. Wow, and it's sending 3 volts. I should check that on some bigger oscilloscope, really. Yep, TC3 was reading, or I couldn't see dot on the screen. 28 volt, 20.8 volt peak to peak. So 50 kilohertz signal, well, very clear. Duty cycle, let me see what we can do here. Yep, nice. You see. This signal generator is a bit better than TC3 signal generator. It's true 10 MHz oscilloscope against this 500 kHz oscilloscope. However, component tester works, but I wouldn't give so much trust to this component tester. They changed something in this inside of this. It is not tear up video, so I will not open it now. Intention with this instrument was to have something in the field which can confirm if your component working or not working. You know, if you have a 10 mega ohm resistor in a circuit with 10% tolerance, it's not important if it be 11 or 9 mega ohms. And I think they had that in their mind when they constructed this instrument. Besides resistance test, I didn't find any other issue. So do you know that you can use oscilloscope and signal generator in same time? Do you know that? Look at now. It reading what it is sent from 1 kilohertz, 3 volts, okay. But let me go to signal. Let me return sine wave. Yep, that is. Now it's a triangle wave. Look at it. You can use it in same time. You can keep sending signal from its signal generator and keep tracing signal on same instrument same time. That is a very nice feature. Perfect feature for some repairs, I would say. You don't need to bring any signal generator with you. You can use one instrument for both jobs and component tester in same time. I would say it's perfect instrument for what it costs. So yes, my recommendation. Thank you for watching and see you with next video.